Hello Ravencoin lovers, this is Raven Rebels with yet another tutorial. And today we are going to look at how can you use a cloud service such as Heroku to create you want to create a microservice that verifies digital signatures on Ravencoin, and you want to have that hosted on a cloud service. You want to use a microservice. So we will create a simple microservice and we will host it on Heroku from scratch. And we will also verify. It has to do two things. It has to tell us, answer the question, this NFT, which address does it belong to on the Ravencoin blockchain? So we can ask a user, for example, to log into a website, and they can state their identity by having a token. So we have to look up on the network which address this has this token. And for that, we will use Electrum. So we use a JavaScript library for Electrum and talk to a Ravencoin Electrum server. And we will also add some code that will verify that a certain signature message address is correct. Because if you have that and you add it to your backend of your services, then you can add Ravencoin sign in with NFTs to your site. Because your site needs to verify, when a user comes to your site and you say, okay, log in with my, you can only log in with tokens issued from us or whatever. What you do then? Well, you ask the user to sign a message, which is perhaps will be something like sign in to our website.com and the date, something like that, because you want the message to be as specific as possible, so people can't create like man-in-the-middle attack and reuse old messages, or just because you signed some message at one site, some other guy can use it to sign into some other site. Of course, you don't want that. So you want it to be clear, like sign in to mycoolwebsite.com and perhaps a date or something. And you can say that it can only be 5 minutes old tops, something like that. Anyway, let's get started and let's try to make all of this work in 15 minutes. So here we go. First off, we are using Heroku. And Heroku, I thought I had it here. They have a Heroku getting started Node.js. They have a guide how to get started. We have already done this to prepare the demo. But you click an introduction, you install their CLI, their content command line interface stuff. You log in and you use Git and stuff. And then you clone this example that they have. We have already done that. And when you have done that, you do Heroku create and you push the code and you open it. And we have done all of that. But this you have to do before. Anyway, so let's go and check out some code. So if we just open the example code we got from Heroku, we have removed lots of stuff from the index.js file. And just say that, okay, let's use Express. Let's listen on this port. Very important here that it's you take the port from the environment variable if it's there. This is out of the box from Heroku. And we added this stuff. If you go to / we will say hello. So if we open this one up in our web browser, we see hello. No, we don't see hello because the server is not running. Okay, so let's do this. npx node daemon index.js. Nodemon will watch and wait for changes in your file, and it will reload the server as necessary. So now it says hello, but you can, if you add hello to and save, Then it has reloaded, so you just, here we go. Nice. So what you need a microservice that can, one, answer the question, which address on Ravencoin does this NFT belong to? Which address contains this NFT? Two, is this message, this signature, is it the correct signature for this message and this address? That's what you need as a backend. So let's create that. So we want to have one service is like address, and one service that is like get verify. Request response. And to make life easier, the verify should probably be HTTP post. Let's make it HTTP get, makes this example more easier. So you want to have, and it doesn't matter if you ask for address or want to sign in with a NFT, you need the code to check the network for the address for this NFT. And that's why that's where Electrum comes in. It's really nice because when you are using a client for Electrum, you don't need a Ravencoin wallet yourself. You are trusting a Electrum server. So if you go to the Git repository, this one, you can scroll down and say read the docs. And to be able to use this, we use an Electrum client for JavaScript. We already have an example of that on GitHub. So if you go to Raven Rebels and scroll down and you see Electrum client example, you see that we have an example where we're using Code Warrior Electrum. So let's use that one. So we should do something like, let's copy some code from here and add it to our new server. And of course we need to install this one. So we say npm install. We might already have prepared this, but let's install that one. And also copy some more code. We copy some code how to create the client. And let's add that to a async function get address. Send in NFT and it should respond with an address. Like that. And we are connecting to Raven for Life, which is Kral Verde, the developer runs this one. And you will see when we run code later, it will tell you the donation address we just sent. Was it 100? No. We just sent 100 Raven to him. We appreciate that he's running this server. So you copy this client stuff, and then you say you have to connect to the server. And when you have connected, you can do like this one. You can use the client to get stuff from the network. And we want to do like, okay, so we connect and then we ask for what? This is not what we should ask for. We should ask for, or we can use this syntax instead. It's easier. Wait, like this. So we have to go to this Electrum server and look at the documentation, the protocol, methods, and there is something like addresses. Here it is, blockchain asset, list addresses by asset. That is what we want to do. So we can say run this one. And as you see right now, we hard coded to Raven Rebels. So this will now our function quite shitty. It will always only ask for all the addresses that contains the token Raven Rebels, which is not a unique token at all. But and reply that. So let's change address so that first off we can make address async. Now it's async. And we can say const ob equals await get address. And we send in Raven rebels, and we change this to be this parameter, nft. So now we have a service that responds send object. So if we go to address now in our local start server, and we go to the local here, cannot get. Why is that? Because we renamed it to address. Okay, so let's say we should say address. Here we go. Now we get all the addresses that contains the token rebels. Nice. So this is important. Now we need to add some error handling. Let's say that this method or function is invoked with an empty NFT. Let's throw an error. Something like that. And haha, I forgot. Okay, sorry. So if we by mistake should call this one without a argument, we should get a error. NFT. Okay. So now we have to add some try catch stuff here. And now we should send an error. So let's look how Node.js express error. We know that you scroll down a bit to get the best example. This is the one we need. So we want to say that something shitty happened. Error equals error. Like that. So now if we error argument is mandatory, it's okay. At least we have error management, error handling. And the NFT, we want to get it from the URL, of course. So we want to say request query NFT. So now it will be whatever if you send in NFT, we have here already friend rebellious red. It says error argument NFT is mandatory. Why does it say that? So this is the, sorry. And you see that we get an object where you have the address as key and then the value is amount. And that's not really what we want. What we really want is just the address. And we expect everything to be, in this case, to be NFTs. So we want it to be unique. So we say that ask for this stuff, and then we expect we want to extract the keys, and we also we have to have code also that closes the connection. So let's go to where was that? this one, we need to close the connection as well. Let's start with this. Keys. The address should be the first key, like that. Now it should be able to reload, and now we only get the address. And that's not really what we want, because we should reply with an object which contains address. So we do it like that, so we get address better. That's a lot better. So the address is this one. Okay. So now we have a service where you can ask which address contains this NFT. Let's check out the error handling, because what happens if, for example, NFT is incorrect? That's one thing, but what if keys length, there are no keys? Should we throw an exception, or we can do that? Let's close the connection, and then let's say that we couldn't find it. That's it. So what if we add a number 2 here to rebellious red 2? Doesn't exist. Error could not find NFT. Nice, it works. It's good enough. Now we are 50% done, because we have an address where we can check up the address for the NFT. The next stuff is to create a endpoint for, this is lookup address. Let's create another one, which is verify digital signature. Okay. And what should this little guy do? Well, now we should have like NFT equals request query NFT signature. And message. And then we should also check the address, and we do the same way. We just say get address for NFT. So when we are here now, we have the signature and the message and the address. How can we verify it? Well, we will be using the helper library from Raven Rebels, Ravencoin message. So we go here and we say install this one. And we check out the example here, where you see that this is how we use it. So this is how we import it. Let's add that. And we don't need a sign. We are only here to verify messages. We scroll down the example and say, okay, this is how we verify a message. Message, address, signature. And let's say that in Happy Flow, we send back NFT, signature, message, address, verified. So we have to send in the query parameters. You can change it to HTTP post if you do it for yourself. But for this demo, we make it a get parameter is easier. So to run this code now, we need to first we can run our own. Let's go to our wallet and see if we have we do have a unique asset here. Let's copy the name, and we can use our own service, right? our own service to check out where it's located, and we have to URL encode this one. So now we're using, oh, it's not running. Okay, something's wrong with verify, sorry. I always forget this arrow functions in the argument. So we run our own little service, and it helps us to understand that this is the address that contains this NFT. So in this case, we go to the wallet and we say sign message. This is the address. Let's say it's Elvis Presley would love Ravencoin. Let's sign that message. So now let's try our verify. So this is the NFT. Now we have to add the message, and the message we have to URL encode. There we go. Now we have the message, and now we should add the signature, and that equals the signature. And it crashes. Signature, invalid signature length. Very interesting. So we copy this one. Of course, we have to URL encode it. Let's do it right. Why doesn't it like it this time? Because now it's URL encoded. Something is wrong. Definitely. Okay. First off, perhaps we should have some error handling. So this is the happy flow. It works. If it does not work, perhaps we should say we send an error, just like we did here. Same thing. Non-base 68 characters. Okay, I did something wrong. First off, this is not the NFT. This is the address. So that's wrong. That was wrong of me. Let me copy the name. And then we should URL encode the name, and NFT should be this one. Could not find NFT. Let's print out some stuff to help out. Oh, now it works. So the NFT, and it says verified is true, which is good. What if we change, for example, the signature and we add a 2 to the end? I don't know what happens when you add a 2 to the end. So let's change the signature to invalid signature length. It did not say that at the beginning, so maybe there's a character ending in signature, whatever. And then let's remove the 2 here. It's notebooks. And now let's select a NFT that doesn't exist. Crash. Could not find NFT. Which means that we have to place this line in the error try catch. So now it doesn't crash. Could not find NFT. Nice. Now it finds the NFT. And what if we change the message to 2 L's? Now it's false. It's not the same message. That works. What if we rename the signature so it doesn't have a signature at all? Signature 2 equals invalid arg type. So it should, this verify should have something like if not NFT or not signature or not. Then you can send error saying that NFT signature and message are mandatory parameters. A lot better. A lot better. So now actually you have everything, because when you have this, now you can, the user comes to your site, you say you are welcome to log in. What is your NFT? Perhaps you have an input field, you enter the NFT, and you can fetch the address based on the NFT to help the user understand. Because if the user is using a wallet like this one, they have to sign it by address, so they have to know the address. It's not so easy. If you use a service such as sign.ravenrebels, for example, we make that very easy, because this is the wallet. You just click on the NFT and it tells you the address, and so let's use this one. If but this one has to be but anyway, you see how easy it is. So you can just click on something. And we are also working on this Ravencoin Chrome extension. Works in Brave and Chrome, where a user can import one address only in WIF format. But anyway, you can, like that. Very nice. Copy. So if you have this, you have the backbone, the ground that you need. And then, of course, you have to make your system, however that works, be able to handle this. Like perhaps you set up a session where the first time you verify that the user has this NFT. Perhaps daily or hourly you want to check, does this NFT still belong to this address? Because I can log in and then I send the token to someone else who logs in, and send the token to someone else who logs in. So you might want to check on a regular basis, check that the NFT still belongs to the same address. So now we have all the code we need, and the code is like 83 lines long. Let's push this to Heroku to see that it works in the cloud. I mean, that's the whole purpose. So you have a cloud service. So we go to the documentation for Heroku, and we see that you should do git push Heroku main. So you can do git state, you can do like git commit am, which means automatically add all the changes I've done with the commit message. Changed stuff. Very stupid commit message, but anyway, let's do that. And now we have to use this git push Heroku main. This will send everything to Heroku. And then we can do Heroku open to open it in our web browser. It's always nice if you have server-side stuff that you break it up in different services so you can manage them independently. Now it's done. Let's do Heroku open. Nice. So now we can say address and equals. Let's what was the name here? Let's take this address and we have to URL and we already did URL encode it. Nice. And we say no, sorry, not address equal address NFT equals. Nice. And we get to address and it works. So nice. And let's pretend that you have given me the message like Elvis Presley is alive. Now I have to sign the message Elvis Presley is alive to sign into your site. So now we say verify, and this is the NFT, and the message should be, so where I'll encode that to be sure. And the signature, we need to URL encode the signature. Nice. And now you see that this is the NFT, this is the signature, the message address, and it's verified. If we now change the message and say Elvis to Presley is alive, then verified is false. So the whole concept is that you give the user a unique message for that user to sign. Be sure that this message has a context, like it should be something like sign into and then your website name, perhaps also date, because with the date then you can validate the message and say that your the signature can tops be 5 minutes old or 2 minutes old, or and also it helps the user to get a message that's because if you go to some shady site and it says hello, do you want to log into Facebook, you would probably say no, not on your site. So if you just give them something random, then it can be misused on other sites. I can take your signature and log into something else like that. So be sure to have a message that's specific to your site, and also probably also timestamp, something that you know that it's very unique for this situation. It's not reused. So nice. Hope you like it. Not so much code. It was 83 lines of code. We will not publish this code because this is editorial content where you're supposed to do this yourself. If you like this video, please give it a like. If you have anything to say, drop a comment. You're free to share this one. And if you want to interact in any way, please look us up on Twitter @RavenRebels. Have a nice day. Bye.